the class today is about what? Is it only Malloc? Or you're going to talk about the printf stuff?
No. I'm not talking about the printf project. We are talking about Malloc.
Okay.
Yep. All right. So officially, you're welcome to another session of our PLD discussion, and today we are looking at practical application of Malloc, or what I would love to call dynamic memory allocation. Hopefully everyone joining this session was part of the previous session where we looked at the theory behind dynamic memory allocation. If you weren't in that session, the video is available on YouTube. You can watch it anytime that you want. But today, we are going to try to get into the practical use of it and probably try some questions, answering some questions on it and the thought process behind answering those questions. Okay, so that is what we are going to do today. We are not talking about printf. In fact, I'm yet to even read the printf project, so I can't comment on it if you have a question on it today. So for today, we are going to delve more into Malloc and its application. And just a quick recap of what we did the last time. If you remember, the memory layout of your RAM, as we said, for a program to run, we have something like the stack memory and the heap memory. Okay, so those are the two things that we are going to focus on, especially the heap memory. That is where the dynamic memory allocation takes place, and for that matter, that is what we will be looking at more often. Okay, and we've established the fact that with some programs, there is a reason to choose to store stuff in this heap memory. Okay, the heap memory allows us to keep information there for as long as we want. Okay, so that is the biggest advantage that you get when you use the heap memory. Then also it allows us to manipulate the information that we save there, so we can make changes to them anytime we want. Okay, unlike the stack memory, with the stack we do not control it, so things are done automatically. They are done automatically as the program runs. Okay, that means that from what, if you remember last time, we said that with a stack memory, if this is your stack memory, what happens is that every function that you call in the course of running your program will be allocated a frame. Okay, so will be allocated a frame. So we usually begin with the main function main. Then main will get its own frame. If main calls another function, that function will also be given its frame. If this function also calls another function, it will be given its frame. We have it going down like that. Okay, and as soon as this function is done running, it returns its result to the one that called it. Then that means that we lose this frame. Okay, once you are done, we clear you off. Then you give your outcome back to whoever called you. When this is also done, it gives its report to this, and we clear this. So this is like, if in terms of governance, you say an ad hoc committee that you created for a specific task. So as soon as they get the task done and they bring you the outcome, you dissolve that committee. Okay, so that is what is happening to the stack frames. As soon as this function is done, we dissolve that frame, we return the outcome to whatever called it. In the same way, we return back until we are done, we clear everything inside the stack memory. With that being said, you realize that if you call for anything, if you store anything inside any of these stack frames, you should remember as soon as that function, that specific function in which you are calling you are storing whatever you are storing there, as soon as it is done executing, you are going to lose access to that storage. So if you stored it inside the stack memory, as soon as that function that contains that frame that contains is done or has gotten its result, that frame will be removed. And once it's removed, it means what you stored there, you do not have access to it. So anytime you want to create something or assign a value somewhere, okay, in a memory location such that that thing will persist for a longer time until you decide that you no longer need it, then you should be looking at using the heap memory. And the only way we do it is through what we call dynamic memory allocation. And we've learned that with the help of the function malloc, we can how do I call it? We can create some space in the heap memory to accommodate the data that we want. Okay, so that is basically what we are going to be looking at today using malloc. From last session, someone asked the question, when do I know that I should use the heap memory, and when do I know I should use the stack memory? And I said that with the stack memory, you do not decide. Like the program finds it that, oh, this is inside a function and it needs to be in the stack memory. If there is a reason, like the moment you begin thinking about it, there are two things that you should be looking at. Are you thinking about the scope? Should this thing that you're about to create, if it is an array, the array that you're about to create, should it last beyond the execution of a particular function? Okay, so if you want it to linger around for a while before you finally remove it, then keeping it in the stack memory is not an option. If you are looking at, okay, with this array that I am creating, I want this array to be around until, say, all these other functions have run, because I'm going to need the results, the outcome in other functions. I'm going to reuse it in other functions. If that is the case, then you need to have it in the heap memory. For those of us who are in ALS, what we realize is that majority of the time, our programs, usually we have just one file. Okay, so you end up writing the whole program in just one file called, for example, main.c. Then you run the program. Okay, so sometimes you don't see the application of these stuff that we are talking about. But what you should remember is that a program that works and achieves an outcome, like it's in real life programs, you have multiple files. In fact, you can have thousands of files in just one single program, okay, or less or more. It is possible. So what we are saying is that if I need to create something, that would have to stay in that memory location for a long time so that we can always have access to it beyond the existence of a particular function. Then I'm looking at using the heap memory. And that means that I have to do dynamic memory allocation with the help of malloc. Okay, so that is the first reason why you want to do that. Then the second reason why you want to do that is if it is, for instance, an array that you want to create. After creating the array, do you want to be able to make changes to it? You want to be able to make changes to it. You want to be able to increase the size of that array or decrease the size of that array. If you do this in stack memory, it's not possible. After you have created the array, you have assigned it some values, or after you have created it and there is an allocation in the stack memory for it, you can't go and change the size of the array. For that matter, if you need to do something of that sort, I need to be able to manipulate it. Then I should be looking at using the heap memory, for that matter, in dynamic memory allocation with the help of Malloc as a function. Very important. So those two things should guide you anytime to make a decision whether you want to use Malloc or not. Okay. Then another thing you should remember is the return type for Malloc. So you should remember that Malloc will always return a pointer. And by now, I believe everyone knows what a pointer is. Pointer basically is a special variable that points us to a specific location. Okay. So it only keeps the address. So let me see, specific location. It keeps the address of a specific memory location. Okay. So if you use Malloc to allocate space in the heap memory, say you have allocated this size of space and each of these grid is 1 byte grid, then what is happening is that Malloc, when you use the function Malloc, is going to return a pointer that points you to the address of the first item here. The first item here. So that is one thing you should also remember, that Malloc points us like it returns a pointer, and that pointer points to the first item in that space that has been allocated. Okay, so the first byte or whatever, depending on the size that we are allocating or the type of data type for which we have allocated the space for, the very first element is the one that our pointer will be pointing to. But by now we have learned about pointer arithmetic. And we've also learned about arrays. And we realize that an array is kind of similar to a pointer. So in this case, with the help of the pointer, we can also use those array notation, that is the subscripts, the array subscripts, to those in. Okay, so what I'm saying here is that with a pointer, assuming we have a pointer that a Malloc has returned called PT, with this pointer, we can do, if I want the value that this pointer is pointing to, we know that it contains an address, but if I want the value that it is pointing to, I have to dereference it. So if I go ahead and I dereference this specific pointer, you know that I'm looking at the first memory item, okay, or the first element in the memory that has been stored, that has been saved, okay, or allocated in the heap. So by dereferencing it, I'm going to get the value in here. What if I want the value here? Okay, if I want the value here, with the help of pointer arithmetic, we should also be able to go a step ahead to get it. So in this our case, if we want the next memory location, we can quickly do this, the pointer plus 1, then we dereference it. So if we do pointer plus 1, we are pointing to this location. And by dereferencing it, we are getting the value that this location contains. In the same way, if you do pointer plus 2 and dereference it, then we are looking at the next memory space. What is the value inside there? Okay, so that is how we can easily get access to it. Remember that this memory space, the very first one, is known as index 0. This one is index 1, this one is index 2. So this, as you can see here, can be also written as pointer plus 0. Then we dereference it to get the value in here. Pointer plus 1, we dereference it to get the value in here. Pointer plus 2, we dereference it to get the value in here. So depending on the specific location that you want to get to, you can always add the index to the pointer, then dereference it to get the value that it points to. So if I want the element at index 5, what I can do is pointer plus 5. Then I dereference this to get the item at index 5. There is another notation, that's the array notation that we can use. So instead of using pointer arithmetics to access the values in here, we can equally use the array notation. And that one, once our Malloc has returned this pointer, all we do is this. By doing this, we are saying that I'm looking for the value at index 0. In the same way, by doing pt1, I'm looking for the value at index 1. By doing pt2, I'm looking for the value at index 3. The same thing, pt5 will take us to the value at index 5. So you can use this notation or this notation, but I feel that one is simpler than the other. For that matter, I prefer to go with this. Okay, but it's good you know both of them so that whenever you see a syntax like that, you appreciate what it means. In summary, this is basically the practical application of Malloc. Every other thing concerning the tasks you are given to solve has to do with other things. It has to do with coming up with an algorithm. But the most important thing that has to do with Malloc is you understanding that it returns a pointer, and how do you use that pointer to access those individual spaces that it has allocated in the heap memory. Let it sink. So all the stuff about the question that you get, those ones are extra things. You just need to think through them, come up with an algorithm to solve something. But the most important thing is for you to remember that anytime you are creating a Malloc, you are just returning a pointer. So if you return that pointer, how do you access the individual spaces that this Malloc has created? That is what you are interested in. So far as you can access them, you'll be able to use them for almost anything at all that you want to do. Okay, now the next important thing to look at is how do we even know how much space to allocate? Okay, so to understand Malloc, you need to go ahead.
Please, before you proceed, you said the very first thing we should look out for to decide that, oh, we are going to be using Malloc, as in, sorry, I don't quite get that. The very first thing you pointed to.
Yeah, so if I get where you're coming from, I think when I was making reference to when to use Malloc.
Yes.
Okay, so you realize that even for the tasks that were given on Malloc, you could do it without Malloc. There's a possibility. Okay, so how do you decide whether you should go with Malloc or not? That's what I was trying to explain. That even though there are some tasks that I can do without Malloc, I can do them in the frame, I mean the stack memory. Maybe for the sake of ALX had already told us that you are doing Malloc. So you know that this one you have to use Malloc. But what I'm trying to say is when you have no clue, like no one told you, you are building your own stuff and you need to determine what to do. Should you use Malloc for this or not? I mean, should you use the heap memory or the stack memory? That is when you look at, well, if I'm going to use the heap memory, then that means that I can have access to the information I keep there. I can have access to it until I am done. Like I feel that I should clear it before I clear it. Because if you don't clear it, it will be in that memory for as long as your computer is on. So you always have access to that specific information. If you need something like that, then you know obviously this has to be malloc. The other thing is that when we use the stack memory, the stack memory is usually phased. So for instance, if you are going to allocate a space for an array, before it does it in a stack, you would have to tell us the size of that specific array. Okay, so you have to go ahead and tell us from the beginning that, oh, I want to allocate size of, say, 2 to a specific array. And this array will be created in a stack memory. But the question is, what if you don't know the size? What if you don't know the size? What are you going to do? You can create a memory, you can create the array in the heap. That means that at runtime, let a person decide what size they want to give this specific array. If you are going to use the stack, you have to tell us the size beforehand. So if I'm going to create an array, maybe I have to give it size of 1,000 in order to accommodate a lot of these things. But what makes it inappropriate is the fact that if I fix a space of 1,000, then the user ends up using only 2 bytes. I have wasted that space. And that is one thing we want to always avoid. It's one thing we want to always avoid. So if you are not sure the size that you require to do something, then we are looking at, hey, we use dynamic memory allocation. So that at runtime determine how much space you should leave for that. When we start solving the questions, this will be more practical. But that is one. The other thing that you should look at it is, if you have created an array of 1,000 size, the size of 1,000 bytes inside the stack memory, and you are hoping that 1,000 bytes is huge enough to contain almost everything that the person is going to enter. If during runtime you realize that, oh, I actually needed more than 1,000 bytes of space for this thing, you cannot change the size in the stack memory. It is not possible. For that matter, if there is ever a possibility that the size is going to increase or will have to be increased at one point in time in your application, then go with dynamic memory allocation. Because when you go with dynamic memory allocation, you have the ability to increase or decrease the size anytime that you want during the course of your program. I hope that answers your question.
Yes, thank you so much.
You're welcome. All right. So now we made a decision. We need to use malloc. And I've said that you should remember that when we are going to use malloc, you should always remember what it is returning. So the return data type for malloc is always a pointer. Okay? And if it is a pointer, it is returning the address of a specific space in the memory or address of a specific location in the computer's memory. That could be 1 byte, it could be 4 bytes, it could be 8 bytes, depending on the type of data you are storing there. But it's always returning the address to the first thing, the first item in that space you have allocated. So the more important thing you should know is, how do I access the other spaces? And that's what we have talked about before getting to this slide. So how to access it? You can use this pointer arithmetic notation or this array subscript notation. Either of them is fine. So you can use them to get what you want. Now, even before you are able to allocate the exact size that you want, you need to know the size. Very important. So you realize that the function malloc takes in the argument size. Okay, so practically that is what it is taking, the size. That is what you need to give it. What size of space should I allocate for you? It's like when you have someone who does the booking of your hotels for you. if you ever want to go to a hotel, you have someone who does the booking for you. Obviously, before you move, let's say you run a company and you always take your employees to conferences. And for each time you are going to the conference, you have a specific person, maybe your virtual assistant, who does the booking of the hotel rooms for you. So what the virtual assistant will need is, this time around, how many people are you taking to the hotel, so that they know how many rooms they should book for you. So that's what Malloc is doing. Malloc needs to know, okay, you want me to make room for you or make some space for you in the heap memory, but how much space should I leave for you? So if you go ahead and you say Malloc 10, then Malloc knows that I need to make room for space of 10 bytes. That is its duty. 10 bytes. That's all it cares about. So when it gets into the memory, it goes to get 10 bytes of space. Then it returns to you the address of the first byte. Okay, so address of the first byte. That is what it will return to you, and that is in the form of a pointer. So you need to know the size. Very important. So any question at all you are given, if it has to do with doing dynamic memory allocation, the first thing you need to find out is, what size should I allocate? That's the first thing you want to find out. What size? What size? So depending on the question, whenever you are reading the question and it's a dynamic memory allocation question, the first thing you should be looking out for is, what size? How do I get the size? Because until you get the size, you can't use Malloc. Until you get the size, you can't use Malloc. So whatever the question is, we need to know the size. And usually the size will be determined by how many items or elements we are going to be storing in that space that we are going to keep. How many elements are we going to? So if it is an array, for instance, our question is, how many elements will be in that specific array? Then what type of data are those elements? So the data type. Okay. So we are looking at the number and the data type. The number and the data type. So the actual size is equal to the number, say n. Let's say n is representing how many elements this are going to be stored in that memory location we are going to receive. If n is the number, then the data type, what type of data? So n multiplied by size of. So you use the size of operator to get the data type. So the size of the data type that we are using, that will give us the size that we should pass to Malloc. So in summary, we can say Malloc, then in this specific example, n times, then we use the size of what data type? Is it character? Is it double? Is it integer or float? Which of them are you using? So when you do Malloc of this, Malloc will now return. Don't forget, it's not going to return the size for you. It's going to return the address to the first element in that space that it has, or the first byte in that space that it has allocated. Is that understood? Any questions here before we take our first question? We take our first practical question, I meant. Any questions? Okay, so I believe there are no questions. Let's move on. So we have mentioned that we need to know the size. We need to remember that it returns a pointer. Then we need to be able to access the data passed to it, or the data that is going to be stored, or the individual, let me not say the data. we need to know how to access the individual spaces that is going to return. So these are the three things about Malloc. Very simple. Just find the size. What is the size? Then 2, remember that it's going to return a pointer. 3, how, with the help of that pointer it is returning, how do you access each space? Because you may be asked to go and put specific information in each space. You may be asked to go and pull out specific data from each space, okay? So that is what is important to us. In fact, when you look at the use of Malloc, this is like the important part. Because if you create the space in the heap memory and we can't access it, what is it relevant? We need you to create that space there so that we can access it, we can send data there, and anytime we want that data, we can get it. Okay, so the most important part is accessing the data, and I've talked about it extensively, that we can use pointer notation in the form of something like this to access the data, or we can use the array substrate notation in the form of this to get access to it. So let's take a look at the first question. Okay, so hopefully you see my screen. It says that write a function that creates an array of characters and initializes it with a specific character. Write a function that creates an array of characters and initializes it with a specific character. So as I said earlier, this question in particular doesn't say anything about using Malloc. It says write a function that creates an array of characters and initializes it with a specific character. Okay, it hasn't said anything about Malloc, but the question you need to ask yourself, what is the size of this array that I need to create? If I know the size of the array that I need to create, then I can use the stack memory. If I know the size, then I can use the stack memory. If I don't know the size, and probably the size is going to be determined during runtime, then I have to use the dynamic memory. That is the heap memory. Do you understand it? Just that part. Like the question is saying, write a function that creates an array of characters and initializes it with a specific character. Assuming I told you that creates an array of 20 characters. Then I've already given you the size of the array, so you can use a stack memory. But if you are going to make your program such that you would need to use get the size of this array during runtime, then we have to use Malloc to get some space for it, because we are writing a function that different people will be using. Okay, so someone may decide to create an array of 20 characters. Another person may decide to do 1,000. Another person may decide to do 500. So for us to make room for that, we need to use Malloc to do that. I hope it makes sense. So that's the first thing. Always. But if you even get this, you should remember that this particular task is under Malloc. So the first thing is they are asking you to use Malloc because the task is under Malloc, or we are discussing it here under Malloc. So obviously it's telling you that it's a Malloc question. But practically, if you were the one facing this scenario and no one is telling you to use Malloc, you have to think through it and see, should I use the stack memory or should I use Malloc or dynamic memory for that matter? And you draw that conclusion based on how you are going to get the size of the array. Okay, so that's what I was trying to explain earlier. Unfortunately for us, we've been given the the prototype of the function we have to create. We've been given the prototype here. The prototype speaks a lot of volume to you on how your function is going to be. So please, anytime you are given a task and you are given a prototype, pay attention to the prototype. It tells you a lot. Okay. So over here, what a prototype is telling us is that we are going to return a character pointer. That's the first thing the prototype is telling you. Okay. I wish I could copy this directly to here. Ooh. Yes. I think it should work. Oh no. Why? Okay. Great. So this is the prototype that we have been given. This is a prototype that we've been given. Okay. So with this prototype, what it's telling us is that the first thing is this: what is the return value? Remember how to use your prototypes. This is the return value. Okay, so what is the return value? It's equal to a character pointer. This means that no matter what you do, you should declare some sort of variable with this return type, okay, or a pointer for that matter, because it is a pointer. So in solving this question, when you define a function, there should be a pointer here. So let's say pointer to the array. Let's say that is how we want to call it. There should be this definition somewhere inside the function. This declaration somewhere inside your function's definition. Okay, and essentially you are going to be returning pointer array. So that's the first clue that the prototype gives you. This doesn't only apply to Malloc. In fact, we haven't said anything about Malloc right now. This is general. Anytime you are creating a function. So anytime you are given a question that says write a function that does this, write a function that does that. That's if you are given a prototype. That's the thing you want to pay attention to. What is the return value? So in this our case, we are going to return a pointer. For that matter, we need to declare one. We need to declare a pointer even before we start. Then our function is called create underscore array. That's the name of the function. So you can't go and use a different name because you've been given a specific name. Create underscore array. Then when we come to the parameters, this function is being passed two arguments. The first argument is the size, which has been given as an unsigned integer. Hopefully by now you know what an unsigned integer is. This means you're not looking at positive negatives, like there are no signs. So essentially they are all positive numbers. Okay, that's for the size. Then this is a character. So this question, if that is all the person gave you, you can say it's a bit incomplete. That is why sometimes they give you other information so that you have knowledge of it. What are we going to use this size for? What is it? Like, what is this particular integer? And what are we going to use it for? So if you go to the platform, if you go back to the platform where we got the question from, you realize that they are telling you that this size that you are going to pass should be the size of the array. Okay, that should be the size of the array you are going to create. Remember that the question said you should write a function that creates an array. So now they are giving you a particular integer and they are saying that let that integer be, sorry, I keep mixing this up. But even though it's synonymous, I mean the number of elements, okay, number of elements. So keep that in mind. The size here they have given is speaking specifically to the number of elements in the array. Okay, even though you can call it the size, but I just want to be careful not to confuse anyone. So we've been given, I hope I still have it. Good. This is a prototype we have, okay? And we are saying that this size here is the number of elements in the array we are going to create. And each element is going to be initialized with a character. And it says that we should initialize each element with this character C. So it is this simple. The question essentially is saying that this function that you are going to create should create a space in the heap memory. Then for each of the spaces, individual spaces that is going to allocate, space C, there's character C in each of them. It is that simple. So we have learned already that Malloc will go and give some space in the heap memory. Okay. So let's assume this is how it looks like. So let's say the function we created, we use it and Malloc actually left this space for us. All that we need to do now is, okay, let's fill all these facts. That's all that the question is asking us to. So create space in the heap memory, then make sure that each of them is filled with this character. That is all. So for us to use Malloc, the first thing we need to know is what is the actual size of memory that we are going to keep. And I've said that before, I think, where was it? Here. That the number, how many elements times size of the data type. So when we come here, if we want to know the size that we should pass to Malloc, okay, size will be equal to, say, this unsigned integer size. So they are given a size times each of them. We are going to put a character in there. So times size of character. Okay. So during last week's session, it was last week, this week, during the previous session, I explained why we need to use the size of operator. Why, even though we know that characters may give us 1 byte, we still need to use this. All right. So this is how we end up getting the size. That means that I can actually call Malloc and say Malloc size times size of. Please don't miss this two. This size is coming from what he gave us here. Okay, so that's like a variable that was given to us, was passed to us as an argument to the function. So we'll have here size times size of character. Let me ask the question. I haven't asked the question since we started right now. Okay, so before I ask the question, remember that it's supposed to return what? A pointer. So the first thing we did was to get the size. Now we should remember that it's going to return a pointer. For that matter, we probably would have declared a pointer here, say character pointer, say pt array. Then we'll come here and say pt array is equal to this. Okay, so someone should tell me, after I have done this, if I go ahead and print out pt array, what do I expect to get? If I write a printf statement to print out pt array, what should I expect to get? Yes, anyone to help us? Hi. Are you all here? Share with us, yes.
Hello, Doc.
Hi.
Yeah, I think we're gonna what we will have as the outcome will be 4 because an
Will be
assigned
what?
integer will be 4.
4.
Yeah,
Okay, explain.
because here the size, which is an integer, understand, is 4 bytes, and then a character is 1 byte. So we multiply that, it's gonna give you 4. That's what I feel.
Okay. All right, you let me listen to other people, then I'll comment on that later. Yes. They should come be here and not be talking. Otherwise, we need to keep quiet. We all sit here. So please talk. Talk.
You go over go over your question, please.
The question is that now we have done this, okay? We've gone through all these steps. If I take this and I print f of this, I use print f. I don't want to express it because when I express it, I would have said the answer. So if I print f of this, what is it going to print for us?
Look,
Hi.
what I'm thinking is probably since the first size we are not getting the actual size of, so I think the value there would be equal to, I think, whichever size we specify multiplied by the size of the character we are printing. So if you have
Okay.
printed a single character, then it's going to be the size you specify multiplied by the actual size of the character you're printing. So if the size is 1, then the size of the character will, I think, be still 1.
Okay. Please remember this.
Hello.
Yes.
I think by the time we print that PTA, it will return a pointer to the space of 4 memory it created.
Thank you.
Yeah.
So PTA is a pointer. So whether I understand we haven't passed the value to this one. So however, if values were passed, then we print it. Oh, sorry, we do the calculation and everything. What we remember is that Malloc is going to allocate space, but what it is returning is the address to this particular one. So if you do printf of this, it's going to give you the address of the first member or the first element or in the 0. That's what I wanted us to remember. In the 0. For Tony's reply or answer, this is a variable. So at the end of the day, when you are calling the function, you have to pass an actual value there. So it wouldn't be considered as the size of integer per se. It's just a value, like it's an integer value that you will pass. So that means that if I put 10 there, it's like me telling you that, okay, I want you to pass 10 characters to a specific memory space. Okay, but for the question that I was asking, I was interested in the outcome of this. What is the return value? The return value is an address. For that matter, if I use printf on this, I'm going to end up with an address. Very important. Okay. So for those of you who usually struggle with the tax that ALX gives us, when you get some form of understanding like this, or even before you understand it, the other thing that you need to pay attention to is that sample thing they give you, the main.c file they usually give you. Okay, they cut it and put the files in there showing you that after you have written this function, this is how we want to be able to use it. And when you use it, it gives us this kind of result. Okay, so as I said, we'll take some time and see how we would open the internet and get those things looked at. Okay, but for now, all you need to know is that whenever you're going to call this particular function, say create underscore array, it's going to be something like this: 10, then I pass a character, say h. This is what it's going to look like. Then when you go into your own definition of the function, we essentially want Malloc to allocate 10 spaces in there and put h in each of the spaces. So you have to define the function that is able to do that. So now the step ahead is for us to define that function. How do we define that function? Okay, so we have this, and usually when you have, maybe I should use the, let me use the editor. But if you have any questions, just ask your question. This is taking longer than it should. If you have a question, just go ahead and ask your question. Okay. So for now, let's just create a function. But I'm going to the internet to get something. I don't want to show that here. That is why I'm doing it behind the scene. Okay. All right. So to simplify things for us, I'm just coming here to get the name of the file. Okay. So there is a file called this. There's a file called 0 create underscore array. That's the name of the file. All right. So we are going to create our function in here. And already we've been given the prototype of that function. So when we come, you put your prototype in here. Then the definition of the function. You should remember, even before you do any other thing, remember that you have to declare a pointer. So give it a name. In this our case, we are using this as the name of the pointer. Then you are going to return that pointer. So at least, if for nothing at all, the prototype of the function gives you an idea of this thing. You need to return a pointer, a character pointer. For that matter, the first thing you need to do is declare a character pointer. Then eventually you are going to return that particular character pointer. So you have to go ahead and do that. Okay. The next thing that we need to do is, now what is the function asking us to do? The function should be able to create an array. But before we'll be able to create that array, we need to allocate some space in memory for it. how do we allocate that memory space? We need to use Malloc. And to be able to use Malloc, we need to know the size that we are passing. And we have already discussed that. So I can say we know that Malloc will return what a pointer. For that matter, this particular pointer that we have created should be equal to Malloc. Then what is the size? The size is this times the size of operator for character. And we've discussed this before coming here, so you should know. We have a problem here. Anyone to unmute and tell us what you think the problem is here? I'm showing the error message that is coming to you so that you can see. So unmute and tell me what you think it is. Yes.
It's not been declared. The function has not been declared.
But inside this particular function, Malloc is giving us an error. It's not necessarily with regard to the function we are creating, but Malloc. So ideally, we can say Malloc has not been declared, but how do we declare Malloc? That's the question, essentially. Yes.
I think it should be in an H file or something.
Okay.
Hello, Doc.
Hi, Tony.
I think the Malloc will return a void. Send on a void pointer.
Yes. It will return a void pointer, but once we are assigning it to this, it's really not a big deal. Okay. Read the error message where it says implicitly declaring library function Malloc with type void. What does it speak? Those are the things we should learn, like understanding those things.
Hello, Doc.
Yes.
I guess you should.
We did not include the header file. That's the standard library header.
Thank you very much. So this is a library file that we are using, a function that we are using. So we need to include a header file. So in the same way, we are like saying you need to declare that function to use it. But we didn't create that function. It's part of the standard library. So we need to have the standard library included in our code. Okay, stdlib.h. As soon as you bring it, you see the underline that was here is gone. So now it's like, oh, now I know the prototype for this function because the prototype is inside this standard library header file. Okay, so we can go ahead and use it. So even though last week I think I explained this, even though this returns a void pointer, sometimes they will tell you you need to cast it to the type of data that you want. So in our case, we cast it to say character pointer. Okay, that is acceptable. However, it's only in recent times, it's only a few compilers that will throw an error if you don't do that. Most compilers understand. So without doing the typecasting, they don't give you any problem. So you can go ahead and do it without typecasting. Okay. Now, we know that this is retaining the size, it's returning the address, okay? So here, what we're trying to do first was, let me use comments and say, allocating enough space for all array members. That's what we're doing. Now we are done allocating the space. So what do we need to do? We need to access each of these space and put that character inside each of them. So essentially, this is Malloc. Like you are done with the Malloc part. You are done. Like Malloc is just assign space. That is all. You have finished assigning the space. But obviously, all these concepts that we are learning, we don't get to use them individually on their own. Like they are all put together to make the program that we are building. So I've used Malloc to create space inside the memory or the heap memory. Now I need us to put a character in each of these spaces that has been assigned to us. How do we do that? So assuming that the size here is going to give us 10, if this size, depending on the parameters that were passed, is going to result in 10, that means we are going to have 10 byte space reserved for us. But how do we end up putting a character in each of these spaces? Okay, so that is what will be our next thing. The next thing is for us to, put a character, in this case, character C, in each of the memory locations. So that is what we want to do. How are we going to do that? Any ideas? Let me hear from you. Any ideas on how we are going to get that done? Yes, kindly speak up. Oh, you guys, you don't make the class interesting. Only a few people talk.
I guess by
Yes.
moving through the
Great.
array pointer, right?
Okay. So now we have a specific address. We have an address to the first byte in that space that we have allocated. And we can, with the help of a loop, we can look through each of these spaces and go and put the element in each of them. But how do you access each of the spaces? We've already explained that you can use either pointer arithmetic to access each of them, or you can use the array subscript notation to access each of them. And I prefer to use the array subscript notation. So that means that we are going to get to put it inside then using the array subscript notation. Okay, so if I go ahead and I do something like this, say this, okay, and put 0 here, and say it's equal to, say, C. Somebody should just explain this line for me, just this line, exclusive of what we are doing, just this line. What do you think? What does it say to you? Okay, someone should explain that to me. Let's see if you understand what's happening.
I think what it says to me is that on the position of index 0 on the array, C should be allocated to it. Like C is assigned to that position, index 0 as the first element in the array.
Thank you. Okay, so that's exactly what she has said. As we know, what our Malloc has done is it has gone to reserve space for us. Okay, and it has returned the first one, the address to it, and we are calling that PT array. Okay, so if we use PT array and say 0, that means we are referring exactly to this space. So if I now come and say this is equal to C, it means that that character that is passed in C, remember C as we are seeing here is not the letter C, it is a variable. It's being passed as an argument. For that matter, it's a variable. It doesn't necessarily mean that it is C that we are going to store in there, because the C is containing a value that you will pass. Okay, but for now, all you know is that this C is going to be passed to this particular space. So we could do that. We could also go ahead. That means that I can go ahead and do the rest as well. I can go ahead and do, I hope I copy this. I can go ahead and do PT1. They said we should do for all of them the same character. So I do PT1, do PT2, do PT3. But the question is, how many times am I going to do this? If I know the number of the size or the number of elements that the person is going to enter, then I can go ahead and do this directly. But unfortunately, I do not know that number of times. One person can decide that, okay, I need you to get an array of 50 elements. Another person says an array of 5 elements. Another person says an array of 1 element. If that person decided to put 1 as the size, then obviously I have gone beyond what I am allowed, because the person just wanted only 1. If the person wants 7, then my code is not adequate, because they want 7 and I've given only 4. For that matter, we need to use the loop to help us loop through it, depending on the size that is given. Okay, so in this specific case, I actually would want to initiate or declare a variable called counter. But this variable, I'm going to compare it to this, okay? I'm going to compare it to the size so that it helps me loop through it. I'm going to count the number of times I go. So if I check 1, then my count is 1, then I go and put C in that location. After putting C, I come back again, add on until my count is equal to the size. Okay, so if it is 10 that a person chose, then I want to do up to 10. All right, so let me go ahead and do it. Probably when I do it, practically makes sense. Remember that if the integer that was passed is unsigned, you also have to declare whatever you are going to compare it to as unsigned. Otherwise, it's going to throw an error. So we can do this. I've declared a count variable probably for counting. Then I can use a for loop. So let's use a for loop to do this. So I'll say we are initiating count to 0. So that's where we are starting from. Count is starting from 0. If count is starting from 0, then we are going to check the condition here is count less than the size that we're given. If count is less than the size we are given, we are going to do something to it. Then after we are done with that, we will increase counts. If you have forgotten about this loop thing, we've already done a session on it, which is also still available on YouTube. So you can go and watch it to understand how to implement the loops. Okay, so what is happening here is we have declared a variable here, and in this specific side, we are initializing it to 0. We are starting to count to 0. Then we are going to check if this count that we have is less than the size. If it's less than the size, we should do something here. What should we do? We want to assign the character to the specific memory location we are in now. Okay, so how are we going to access it? We are just going to call our pointer array. Then next time around, we pass count to it. Then we say it is equal to C, just as we did initially. So initially, we were putting actual values here, like 0, 1, 2, 3. But now we are putting a variable in here. And what's happening is that when we reach this part of the code, this is what happens. The first thing to do is, worrying. The first thing to do is count is equal to 0. So initialize it. Then check the condition. Count, are you less than the size? So assuming the person passed the size to be 10. So the first thing we are doing is we are checking. Okay, 10 is too much for this example. Let me say 3. The person passed 3. Okay, so the first thing we are doing is count, which is now 0. Check, is 0 less than 3? No. If it is, yes. If it is less than 3, then we'll come inside and come and do what is here. And what is here right now is that we should assign C to pointer to 0. That's because count currently is 0. Okay, so that is what we do. Then after we have done that, we'll come back to this. This says that we should increment the value of count. So count used to be 0. This time around, we are adding 1 to it. So count becomes 1. Then we go back. Count is 1. So 1, are you less than 3? Which was the size that we're given. Yes, 1 is less than 3. So we come in here. Remember, count is now 1. So we say 1, then we pass the value to it. After we are done with that, we come and increase count again. Count is now 2. We come back to the condition. 2, are you less than 3? Yes, 2 is less than 3. So we come here and come and change this to 2 and assign the value C to 2. Then when we are done, we come and increase 2. That's increment. So add 1 to it, it becomes 3. Then we'll come back to the condition. Is 3 less than size? Which is 3? No, 3 is not less than 3. So we break out of this loop. Then we end up returning a pointer. What has happened here is that when this loop has gone through, it has assigned. Remember that we are using dynamic memory allocation. We are using pointers. So these values that we have created, the C that we have allocated, it has already put them in that memory location. So here, our interest is not necessarily returning those C or that whole array. It has already put it there. So all we need is just the address. We need the address to the first one, because now anywhere we have the address to the first one, we can reuse or find the values that are at all the other locations. Yes, any questions? I hope this thing makes sense. Please let it make sense. Any questions? So you realize that this part that we are doing has nothing to do with Malloc. This is for loops. So it means that if you don't understand the concept of for loops, you won't be able to solve this particular problem. The Malloc part was just this part. It was just one line. That's all. But this is for loop. When we finish, we will use while loop to do it. Does someone have a question?
Yes, hello, doctor. I have a question.
Hi, Daniel. Okay.
Yeah, my question is why is C not in double quotes since it's a character?
So
the value we are assigning.
Yes, let me quickly add. The point is that this C is not C, as you know. Like, it's not a character C. This is a variable name. Once it has been passed to us as an argument in the function, it is just like size. Size is not a number. Like, it's not a number. It is just a placeholder. So at the end of the day, when we are using the function itself, we can pass anything at all. So somebody using this function can decide to say, I am going to call C, I'm going to call this function. This is how we are going to call it. And we'll say something like this. Call it and say 3, then say B. This is how we are going to call the function. So essentially, when we enter this function we have created, this will be replaced with 3, and this will be replaced with that character B. So when we get here, instead of C, anywhere you see C, our code will actually be returning this. So a will be in quotes. Is a character, for that matter, it has to be in single quotes. Okay, but you are just writing the function, and the function uses placeholders. It's like those are spaces that are yet to be filled. So when the person is calling the function, that's when they will provide exactly what you are going to be putting there. Okay, I hope that makes sense.
Yes.
Okay. Great. Any other question? So let's try something for the sake of those of us with the ALX program. I'm going to do something here. Copy the main file. So I already say this thing. You always have to pay attention to the main file that you are given. That is what we can use to test it. You can create your own main file to test it, okay? But at this very moment, I want to just use an already made main file. I need to rename this to 0/main. Then instead of this, put this here. So because of the requirements of that particular question, we need to create a main.h file. Main.h file. Then say if n there's main_h define main_h, then end if. Then let's go and copy the prototype we've been working with. Okay. So this is a prototype, and yeah, now that we have this sorted out, we have a main file. Let's see how this main file is. So that's what that when you are given the tasks, usually they give you a main file, okay, that you can use to test your code. And sometimes the question is so tricky. You need to see the main file to be able to understand the question and what it is requiring of you. Okay, so in this specific case, see how they are using it. This is not a function that we're asked to create. So first of all, let's look for the function where. So they use the function here. They use the function, they are passing 98 and the letter 8. What it tells you is that when you come into your actual function, okay, the size here is being provided to be 98 and it's being provided as capital H. So essentially what you are creating with this is that you are creating enough space for 98 elements, and each of those elements is going to take, each of those space or bytes is going to take the character H, capital H in there, okay? That is what the main.c is giving us. But they went ahead to write other code to pass this buffer to it, and like they return the pointer that you are returning. Remember that this is going to return an address, okay? So essentially what they are doing is that that address that you are returning, they are passing it to what they are calling buffer. Then they now pass buffer to another function they created here called simple print buffer, okay? And that function's definition is up here. What does it do? It takes the pointer and it takes a size. Then it checks, well, this integer here is less than size. What will it do? It finds the modulo of 10, the number modulo 10, then it prints space. In fact, the point is that even with this part of the code, you don't need to understand it. But essentially what the ALX start to give you is they will still give you the outcome of your code, okay? They'll give you the outcome of your code. So I'm tempted to go and open it. But when you run your program, the outcome, you go and compare it to what you were given on the intranet to see whether it is giving you that outcome. So for now, let's just run it. And I'm sure when we run it and it works, you will remember that there was something like that in the program. Okay. So yesterday, someone asked me a question that when you are trying this thing out, how do you test it? Now that we have written our code, in the intranet, they test it for you. They give you the line of code they use to test. So just go and copy and paste it. This is the line of code I've copied from the intranet. Okay, so GCC with the flags, all of these, then main.c, 0create_array.c, then output the file to A. That's what they are doing here. So if I go ahead and click enter, okay, so the error we are getting here is that on line 12, we are using the comment style that they do not want. So let's go to our line 12. Which one is that? Line 12. Okay, so this comment style is not acceptable per the flags that they have given. Okay, so let's see if there are any others. Okay, hopefully there are no other errors. All right, so let's rerun it. Great, now we have our A file here. That's the output that we gave it. So to run this, we need to do .a, then run it. And this is the outcome that gives you. So if you check your intranet, you realize that that was the exact output that you were given. Okay, so this is how you test whether what you have done is doing the right thing or not. But that isn't supposed to even be part of this discussion. What we are trying to appreciate is how we allocate memory space, then how we pass values to those individual spaces that we allocate. Okay, so for those of you who like the while loop over the for loop, you can equally do this using the while loop as well. So basically for while loop, as you may recall, we'll need to initialize count outside. Okay, so we'll do this and we'll write our while loop. Say while, what's the condition here? We are checking if count is less than size. So while count is less than size, do what? We want you to do the same thing. The same thing. Oh, where am I? We want you to do this same thing. Hey, why does it take me there? Okay. Copy just this, please. Copy this. That's all we want you to do. Then we go is to increment or increase this. Okay, so this is the for loop, which we could equally have used a while loop to do the same thing. So that gives us the outcome that we were looking for. Any questions so far? And let's start with the next question. Yes, any questions? The next question says, write a function that returns a pointer to a newly allocated space in memory, which contains a copy of the string as a parameter. That's interesting. Write a function that returns a pointer to a newly allocated space in memory. So we are going to create our own space, and this space contains a copy of the string given as a parameter. So what essentially what it's saying is, with the help of this prototype, let's take a look at it. I mentioned earlier that once given the prototype, you should know the return data type. So this function has to return a character pointer. For that matter, as soon as you define it, just go ahead and declare a character pointer. Okay, so in this case, let me say str, pointer str. Okay, so go ahead and do that. Then this is the name of the function. And you realize that they are going to pass another character pointer, but in this case specifically, you know that it is a string that they are going to pass. So the question, what is asking you to do, once again, is saying that the memory that you are going to allocate, it should contain a copy of the string that is given. So this string that is given here, we want you to copy to create space. So use Malloc to create some space. And this space that you are going to create should contain whatever string that we pass it as a parameter in this function. We understand the question. Understanding the question is like the most important bit. Okay, so I'm saying that the malloc aspect of all these particular things is just a small thing. Here, all that malloc is help us do is allocate enough size, enough space for whatever string that they write. Okay, so you have to now ask yourself, what size are we talking about? Very important. So you say that this space I'm going to create, I'm going to copy the string that I'm given and put it here. So what size should I leave? Because one person can decide to give a string or say Obed. Another person will say Obed is coming. Okay, so we need to know how do we get the size. So if not for this ALX class and you were doing it on your own, there are standard library functions you can use. So the first thing is you can use a function called string length. I think so, yes. There's a function called string length that will tell you the size of the string that will be passed. And once you know the size of the string that will be passed, and you know the string is made up of characters, so the size of each character, you multiply the number of strings by the character, then you get the actual size that you are looking for. But unfortunately, with ALX, we are not allowed to use the standard library files. This means that we have to create our own function to do the counting of the size of the string, how many elements are in a string. Then one thing that you should always remember when you meet such cases is when you hear string, you should know that strings are terminated with what? A null character. If you are going to be able to write a function to count the size of a string, then you need to know this to be able to count it. So you are going to be able to count the size of a string without using the standard library. Okay, if you are doing your own project, you shouldn't even waste time. Just use the standard library. The only thing is now they are teaching us to be able to think and come up with solutions. Assuming this counting wasn't a regular counting of a string, or assuming what we want to do doesn't have a standard library, how are you going to go about it? That's essentially what they are training us to be able to do. We should be able to write our own functions to do the counting for us. Okay, so all that we are interested in with our malloc is to get the actual size of space that we should reserve. Okay, but to get that, we need to know what's the length of that string. Okay, or how many, if you remember, how many elements or characters in this case are in the string. Once we know that, then we'll go ahead and say, okay, there's many characters, say there are of them, n times the size of character should give us a size. But another thing that you also need to pay attention to is the fact that eventually you are going to copy this string that you've been given to a new memory location. So let me try explaining this before we even go to practice it. So assuming that I write this function s up, then pass the Obed to it. What I'm asking you to do right now is that use malloc to allocate space that will take up this. Okay, so malloc has to find out what size is a string that I'm going to put in my malloc memory. Okay, so whatever the malloc space it gives us is going to have something like OBED. But don't forget that we are looking at a string, and for us to have a string in memory, there needs to be a terminating character. End of string character has to be there. So if you go ahead and reserve only this space, without considering the extra space. That is wrong. So you need to know the size of this, but when you are reserving the space, you need to add an extra 1 byte to contain the end of string character. Let me take that again. Take that again. Okay, so we have this function that we are going to define soon. But before we are able to define the function, we need to understand what it is doing. Once we understand what this function has to be doing, then we can go ahead and define it. So this function is actually going to be called this way. We pass a string to it, So the string I passed there was Obed. Okay. So the first thing we need to know is this string that I passed, what is its size? So we are going to write a function that is going to count. That is Obed. So there is 1, 2, 3, 4. There are 4 of them. Okay. So it's now going to tell us that the length of this is 4. So let's say we use n for that. The length is 4. If we are going to allocate the space, we can say we want Malloc to allocate 4 times size of character. If we end here, what is happening here is size of character will be 1 byte. For that matter, Malloc is going to leave 4 bytes of space. And that 4 bytes is going to be this. Say 1, 2, 3, 4. That's O B E T. That is all. But remember that it is a string that you are storing in memory. And anytime you are storing a string in memory, there has to be the end of string character. You can't leave that out. For that matter, you shouldn't end this here. You should add 1 to this. Assimilate as well before we continue. Are you not assimilating it? That is a very important part, okay? So if you don't do that, the checker will give you problems. You may think that, oh, I've passed the characters and everything, but the checker is definitely looking for something like this. So in that memory, it is looking for something of this nature. Now, to be able to achieve all of this, the first thing is how do we get to know the size of this length, this string that we are being given? And as I said, there is a standard library function that we could have used, but unfortunately, ALX is not allowing us to use a standard library function. We have to come up with our own. Okay, so you don't necessarily have to go and create a function, but you have to write code to calculate or check the size of the string that you are passed. So the first thing we want to know is length of the given string. So this is like coming up with an algorithm to solve the problem that you've been given string. Okay. After we know the length of the string, what we are interested in is the size in bytes that should be allocated. That should be allocated. Okay. After we know that, the next thing that we need to get to is how to copy this string to the new location or space that we have created. So memory location. Okay, so let me put memory here. Then finally we return a pointer to the first element of the string or that memory location. So this is essentially the solution to the question that we were given. This is the solution. And mostly you should try doing this kind of brainstorming before you even start writing code. You don't just read a question and start writing code, because like practically you would have a problem, like you're coding something. The thing is just an idea or maybe a task that you've been given. Oh, we need to do something like we need to have a program that's when we pass a string to it, it copies it to a certain memory location. That is what you've been told. So you will now come and sit down. Okay, if we need a program that will copy. Besides, in the practical case, no one is going to give you a prototype. You have to come up with your own prototype. So it's part of the thinking process. If the task that they want to achieve or what you are trying to build, you think that you need, when the person passes the character, or you let your end user give a string, maybe their name. When they give you their name, you need to go and store that name that they are given. You need to go and store it in a memory location where you can have access to it anytime you want. So how do I go about it? Okay, let me create a function that will accept that input as the argument. So this is practically what you do, okay? Let me write a function. So I'm thinking through it. Let me write a function that will accept the name as argument to that function. Then after accepting it, how will I manage to now get this string or name that the person has entered into that memory location I want to create? Okay, I need to use Malloc to allocate that space so that I can then push it in there. But for Malloc, I need to know the size. What size should I allocate? To get the size, I need to know the length of that name that the person is typing. So this is the kind of things that happen practically. Okay, when you are given a task and you see it as just, oh, this is just a question that, no, you have to get it practically. How does this play out? Now we are able to, okay, step by step. The first thing I need to do is I need to get the length. Like, I'm not saying that it comes easily like that. Like, the moment you think about it, you know that this one, you need a length. This one, you need this. This one, you need that. In fact, even sometimes you come up with the steps, but how to even achieve it with a code becomes a problem. You have to do a lot of Googling, you have to do a lot of other research, ask people, talk to colleagues and the rest, before eventually you get a solution with just maybe this particular line. So let's assume you don't know how to get the length of a given string. You need to sit over it. So yesterday I took one of those questions, one of the advanced tasks, and tried to go through it again, and it was like, wow, I don't even know what this is. It took a lot of my time. When I'm sure, I think even the third one, that one even took time. But I was able to write it out, and I'll show how I did that to you. Okay, but I want you to appreciate this. Is like, I think a lot of us in the ALX program wish we had teachers coming to share with us practically what happens instead of us just going to see that. So being here, I'm trying to also help by sharing how these things play out. Okay, so you shouldn't just think about it like just a normal task. It could be a program that you are building, your own software. Maybe because we are still doing C, but when we start doing something like Python that you can use to build a program and use somewhere, you will begin to think about, oh, what can I even build with this knowledge? Okay, so like this idea that we have, what can we actually build with it? We could probably do something. What can we do with it? Then we start practically, we think through them. Okay, so that is the process we go through to get these things sorted out. So let's now try and get each of them done. How do we get the length of a given string. So that becomes the first thing we want to do. Length of a given string. So you realize that this is actually not related to Malloc. It has nothing to do with Malloc. Getting your string length has nothing to do with Malloc. You could have used the string length function to get it, okay, but they are training you to solve problems. So that's what we are trying to do. Length of a given string. How do we get it? So how to solve this, or how to go about the thinking process is this. Just tell yourself, if I have a string, the string will be like Obed. Okay, so how do I count this? I can use the loop to count each member of this. But to be able to count them, I need the terminating case. What will be terminating the loop? Okay, at what point should I stop counting? So I'm going to start counting, but at what point should I stop counting? So if this is a string, then what it actually means is that the end would be this character. So for me to count, I'm going to count until I meet this character. As soon as I meet this character, then I know that I've gotten the size of my string. So I will use a for loop or a while loop. Let's say with a while loop, I am going to initiate a count variable and say count is equal to 0. Okay, and I'm going to check counts. No. So because it's a string, remember that a string essentially is also an array. Okay, so to access each member of the string, we can use the array subscript notation. Okay, so for instance, if the string was passed to you like this, what it means is that you can call this, just as we did with the character pointers earlier. Okay, and this will be the first member, second member, third member. So what you are going to do is, let's check for this of count. Okay, in this count, if it is not equal to this, because the moment it is equal to it, we are not going to count. So if it is not equal to this, go ahead and increase count. What this means is that the first time it goes in count 0, so it checks index of string 0. What is it? It's O. And we are just checking, is it equal to this? If it is not equal to this, then I should increase count. Since O here is not equal to the end of string character, my count now becomes 1. Okay? Then I go back in and go and check the next one. This is 1 here, so I look for 1. This is O, B, D. Let's see, this will be D, and this will be the end of string character. So now we have 1. I come in here, and 1 is B, so it's not equal to this. Once it's not equal to this, I come to increase count. So count now becomes 2. So I come in here, 2, string of 2. 2 is what? E. Is also not equal to this end of character. So I come to increase count again. Count is now 3. I bring 3 here. Count of 3. 3 is what? D. So it's not equal to this. So I come to increase count. Count is now 4. 4, when I put 4 in here, string of 4 is actually equal to this. So this condition will no longer hold. For that matter, I'm not going to count this. This means that for now, count is equal to 4. Count is equal to 4, and that is the length of the string. So we have gotten the length of our string to be 4. When we come back here, the first part has been solved. We have now gotten the length of our string. Now we want to know what is the size in bytes that should be allocated. Size in bytes that should be allocated. We are still using the example where Obed was passed. Okay, so we are interested in size in bytes. Size in bytes of space to be allocated. Okay, size in bytes of space to be allocated. We know from our previous discussion that to get the size, what we need to do is that we need the number, that's the length, that's what we have calculated. Then using the size of operator on character, since each of them is a character. Then we need to make room for the end of string character. So that is how we are going to get it. So here, this will be equal to length of string. So length of string multiplied by size of character. Okay, that's the first part. Then let's add 1 to it. And this one we are adding because we are making room for, when we copy it into the memory, because it's a string, we have to pass this end of string character to it. That's why I'm making room for this. So we'll now get 4 times 1 plus, this is plus 1, that is 4 plus 1, so 5. So what we are going to do is we are asking Malloc to leave a space for 5 bytes. So let's go back to the algorithm we are working with. This has been solved. We now know the size in bytes that we should allocate. That is 5 bytes. Okay. The next thing is, how do we copy this string to a new location? That's the next thing. Now, how to copy the string created to a new location. Something just occurred to me. In all I've been doing so far for the Malloc, I've not checked whether the Malloc returned null or not. We have to pay attention to that. So because the dynamic array from our last discussion, I explained that we can use up all the memory. Okay, so it's very essential that anytime you are using Malloc, you should always check the output, whether it return null, because it can fail. Even though we are saying it's going to return a pointer to a specific location, that's the address that it has reset, sort of. Even though we are saying that, sometimes when you run Malloc, you probably run out of space. For that matter, it's going to return null. So when Malloc goes there and finds out that there's no longer space for you, it returns null. So we need to keep that in mind and always have to check it. The results that we get after we run Malloc, check if it is not null before you pass any value to it. Because if it is null and you're passing value to it, then the program is going to crash. Okay, so we always need to check that. All right. How to copy the string created to the new location? Okay. String given to new location. So we're given Obed. How do we copy this to a new location? And this was given as a this. Okay, and you know by now that we can access each member using what? Using the, let's say, account value here. The array subscript notation. We can use it to access each member. But now, first of all, we need to create that space where we want to copy them to. So how do we create that space? We use Malloc. That means that we need to create, since these are strings, we need to create a character pointer. Okay, so pointer to string. And we say that this is equal to, so we can say pt string is equal to malloc of, when we calculated, I think we got 5. Okay? So we can say it's equal to malloc of 5. That means that this will allocate the space and give us the address of the very first one. 0, 1, 2, 3, 4. So it will give us the address of the very first one. We'll pass it to pointer this. Now we have two things. We have this here, str0 to be O, str1 to be B, 2 to be E, D to be D. Hey, 3, I meant. I'm getting right. String, string, string. Okay, so this we already know. We've been provided this information, and we need to copy these ones here to this location. So essentially, we need to have something like this. pt string 0 should be equal to str0. Then pt string 1 will be equal to str1. So we are going to do this to the end. Then when we have ended, the last thing, since it is a string, we need to pass the end of string character. That will be, I think, 4. End of string character to that. So essentially, that's what we need to do, to be able to copy the string from what's the string that was passed to the memory location that we have created. That is what we need to do. This means that we need a loop to help us achieve this. We need a loop to check. Maybe we set a counter that will check. Okay, for this counter, we are going to increase it until something like this happens. And once we are increasing that counter, we'll pass the value of the pointer string to the value in the string that we're given. I hope it makes sense. Maybe I should just jump onto the editor. I'm feeling tired. All right. Let me jump onto the editor and let's try from there. Okay. So we need to create a new file. Ooh. We need to create a new file called this. Then we're given a prototype. So we copy the prototype. Okay. So now, the algorithm that we derived, the first thing we wanted to do was get size of string. So let's go ahead and try that. How do we get the size of the string? And we have already demonstrated that here. Get to the size of the string, okay? So we just use a loop. In this case, we can use a while loop. We can also use a for loop. So, but as I mentioned, I think, let me not forget this one. Okay, the first thing is, this is going to return a character pointer. For that matter, let's go ahead and define a character pointer. And I'll call it pt string. Okay, then essentially we are going to return that same pointer we have created. Okay, so now let's go ahead with the algorithm we got. Get the size of the string. So how do we get the size? We need to initiate a variable count called 0. Then we can use a while loop to say that while this string counts is not equal to end of string character, we need you to increase count for us. That is all. So this will return count, which is the size of the string, or let me use length. Mind you, you can use any variable name. Sometimes, in this case, I would prefer to use something like the string length. Okay. Okay. So that anyway I see it, I know that that is a string length. Then the second thing we're going to do was size in bytes. So that one we can go ahead and allocate the spaces. We'll do it together. So determine size and allocate enough memory space for it. Okay, so if that's what we are going to do, then let's assign it the outcome to our pointer. Say this is equal to malloc, then our string length times size of character, then plus 1. Sometimes in such cases, you need to be very careful of the arithmetics, okay? Because of the, how is that thing called? Operator precedence issues. So you sometimes have to be very careful. But for this specific case, the multiplication has precedence over the addition. So we could easily get away with it. Otherwise, you need to probably put this in a bracket to force them to do this first before adding 1, as in do the multiplication before adding 1. In this specific example, without it, it wouldn't be a problem. You can see that Malloc is still giving us the error. And hopefully by now you know why we have this error in here. So we are going to correct that by including the standard library std.h. Okay, so now Malloc is going to return this. But as I've said earlier, once Malloc is returning something, check if Malloc doesn't return now. So we need to check that before we pass anything to Malloc. Okay, so we check if you can decide to, depending on the question. So I think this task asks us that if Malloc returns now, we should return now to as the final output. So we can do that by I think of the return now. So we can do this. You can do this, okay? That's just to check if it doesn't return now. But if it returns now, then we return this now. Otherwise, so if it doesn't return now, then the rest of the program will continue. So what is the rest? We need to copy the string to the new location. So that is what we need to do now. Copy the string to the newly or the new location. Let's say that. So to do that, we need the help of a loop. Maybe in this case, let's use a for loop. And let me declare count as a variable. Remember that I changed this to string length, okay? So I can use count as a variable here. Then say for, what are we going to be checking? What are we going to be checking? So for count is equal to 0, let's check if string count is equal to let's check if is equal to, or if it's not equal to, if it is not equal to the end of string character, okay, then we'll do something afterwards. We would increase counts. Now let's write the definition for what to do if this condition is not met. So this is not any different from this, except that this was helping us count it. Besides, we could have used a for loop. So for those of you who are interested, I will task you to go and relook at how you would have used a for loop to count this. Okay, just look at it. In this our case, let's go on to say, once it is not the end of the string, I want you to pass this value, the pointer value. That is, we are starting from 0. So pointer the 0, 1 to be equal to string the 0, 1. Okay, so essentially what we are doing here is that if count is, so we start at 0. We are saying that the location pointer 0 should be equal to what we have here. Okay, and that's what I explained here. Hopefully you understand it. Okay, so what I'm saying now is this: when pointer 0 should be equal to this, pointer 1 should be equal to this, pointer 2 will be equal to 2, like that. Okay, that's exactly what I'm doing here. But when it reaches 4, then we are going to break out of this loop. Okay, hey, did I write an equal to class? Okay, when it reaches 4, then we are going to break out. But remember that by the time we break out, let me die with Obed for you to see. So the string is Obed, str is equal to Obed. Okay, so what we are saying is, for as long as string, let me use I here, is not equal to end of character, okay, I need to have PTI to be equal to STRI. This means for the first one, which is 0, we are going to have PT0 is equal to ST what 0, and ST0 from this string. From this string, the 0 is what? O, the 1 is B, the 2 is E, the 3 is D. So that is what we are going to have. Okay, so in this case, you are going to end up with this 1, 2, and 3. Beyond 3, we would have gotten the end of character. So this would have gotten end of character. Once we get end of character, we won't get into the loop again. So at 4, we won't get into the loop. This means that we are not going to assign anything with our loop. Please pay attention. That's the reason why I came here to illustrate. Maybe I'll walk you through it slowly. So what's happening is, the first time we are starting I is equal to 0. So the first time we start ETS of 0, like I mean pointer 0 is equal to pointer this. Then we'll come and check. What we are checking here is if the string value of I is not this. Okay, afterwards we should increase the I. So the first one, we have done the first one, and now I is 2. Sorry, it was initially 0, so I now becomes 1. Okay, if I becomes 1, we'll come and put it in here, and this is B. It still passes, so we'll go and do this. Then we increase I. I is now 2. We'll come in here, E. So we will pass this. I now increases to 3. So we'll bring it in here to check. For 3 is D, so we've not ended. and we'll come and associate this. Then finally, I becomes 4. When I becomes 4, this loop is going to, we are going to end the loop, okay, or exit from the loop. That's what is going to happen. The moment count becomes 4 in our case, we are not going to come in here. That means that for this specific example we are working with, we are not going to have anything like this. Like we don't have any value assigned to the 4th index of this pointer. We don't have anything like that. So in our code, we have to come out and say, now we know that our count is 4, okay? So we can go ahead and say this, count, because now in the example we are using, count is the final one, so count is 4, is now equal to, then we will pass that value to it. Essentially, that is what we are supposed to do. Oh, I'm tired. Yes, so that is how we are able to achieve that. And hopefully when we run the code, it should give us the kind of output that we want. Yes. So what you can do is you can try out using the while loop where we use for loop, using for loop where we use while loop to get accustomed with them, okay? But the most important part is understanding the reasoning behind what we did, okay? So the third one, I bet you I can't take the third one. I mean, exhausted. But let's see, I think I already did it on Replit. So I'm going to show the code, then walk you through it. I think it should be there. Hopefully. Okay. So this is it. The question says write a function. I hope you can see. I hope you can see. Okay. So the question says that write a function that concatenates all the arguments of your program. That's interesting. So every time what I say is that the more we learn, the more things we do. Okay, so like we build on things. All right. The moment you read this first line, write a function that concatenates all the arguments of your program. You should know that we are talking about command line arguments here. Even if you can't recall that these are command line arguments, when you see something like this, at least this one, should give you a clue that we are probably dealing with command line arguments at C and at B. Okay, and the last time when we were doing it, I showed you they could be represented with any variable. All right, but at least this is telling you that the argument that a person is going to end up passing, we want you to write a function that is going to join all those arguments. Write a function that is going to join all those arguments. Okay, then it gives you the prototype. So at least with the 2 examples we've solved so far, you should be able to appreciate what to do with the prototype. Then these are the comments. But I think there is an important one here that says each argument should be followed by a new line character in the new string. That's very important for you to be able to answer this specific question. Each of them has to be followed with a new line character. Hopefully, when I get time, I'll write an extensive blog explaining this thing, like how to solve this. I'm feeling a bit tired. So the first thing you need to do is find the algorithm to solve this problem. What are the steps that I need to go through to solve this problem? That's the first thing you need to do. Okay, so in this case, I think I read some of them. I'm feeling tired right now. So, Okay, so do you know what I'll do? I'm really feeling exhausted. So what I'll do here is I'll share the link to this replet with you. Then I'll take time to write an article explaining everything that goes on in here so that you get to understand it. But if you have any questions about it, you can equally ask me right now or along the line. But if you have any questions on what we have done so far, just go ahead and ask them. We'll bring the session to an end. I'm getting to my limits. Yes, questions? Any questions for me? Okay, then I believe you don't have any questions, so we can call it a day. And tomorrow I don't think we'll meet, so hopefully Monday, Tuesday we'll make a decision, especially on what I said before we started the session. We'll discuss it and see what to do next. But thank you all for joining and thank you for sticking around. It's been a good time having you here. I'll see you the next time. Thank you. Bye-bye. You're welcome. Welcome.
Thanks, Doc.